Hello, my name is Michael the Groot and we're here at Placerita Canyon. I'm here to talk to you about the rock cycle. Now, there are three basic rocks. There are igneous rocks, metamorphic rocks, and sedimentary rocks. And these rocks interact with each other in certain ways. Now, the first step of the rock cycle is weathering. Rocks get broken down, and then they're reformed, and then they get broken down again. And that's basically the rock cycle. The first rock I want to talk to you about is igneous rock. Igneous rock can form intrusively, that is inside the earth, and also extrusively, that is on the earth's surface. When magma cools inside the earth, it tends to form larger crystals. When it cools on the outside of the earth, it tends to form smaller crystals. Now, some properties about igneous rocks. Igneous rocks tend to be more harder and not as susceptible to erosion as sedimentary rocks. Also, igneous rocks are non-porous. That means that water doesn't pass through them very easily. Also, igneous rocks are formed mostly of silica. They contain 40 to 80% of silica. Some examples that you may know of igneous rock include basalt, gabbro, and volcanic tuff. Hello, my name is Michael the Groot and we're here at the Placerita Nature Center. As you can see behind me, we have great samples of the types of rocks around the Nature Center. Here we have metamorphic rock. This rock is formed from hard, really high heat and large amounts of compression. We also have some igneous rock right here. The igneous rock is formed by magma, and as you can see there's some crystals here. This was probably more of an extrusive rock. It was formed outside of the crust by magma. Lot of cars. I'm here on Sierra Highway and we found ourselves a nice rock! Let's tell you about sedimentary rocks. As you can see, we've got some beautiful sedimentary rocks right here behind me. Now, if you can tell, the sedimentary rocks are layered. This happens because sedimentary is really erosion. It's from rock dust, it's from particles. It gets compounded together in these layers. What this is called is original horizontality. That's when the rock is deposited by water. Now you may be saying to yourself, I don't see any water. And you're right. This is because millions and millions of years ago, this area used to be underwater. As the North American plate moving west and the Pacific plate was moving northwest, the collisions of these two plates caused the Pacific plate to be pushed upward, and that's why we're on a plateau and there's no water here at all. Now, some properties about sedimentary rock. Sedimentary rock is much more susceptible to erosion than, say, igneous or metamorphic rocks. Also, sedimentary rock is where you find most of the fossils. So, I don't see any fossils here, but I'm sure we can find some. And the great thing about sedimentary rock is layers. That guy's...
It's not a tumor.
Anyway, it comes in layers, and that's great for finding fossils, because when you find fossils, you know how old it is. And that's one of the great things that sedimentary rock can do for you. It comes in layers, you can gauge the layers, you can tell how old the fossils really are. And that's what's great about sedimentary rock. You're on the Sierra Highway where there's a...
Stick around.
Hi, this is Sean, and today we're going to be talking about metamorphic rock. What does metamorphic rock actually mean? Well, meta is a Greek word for change, and morph is a Greek word for form. And it is a rock that has been changed from its original form, usually by heat, pressure, or fluid activity, into a new rock. The sources of this change include magma. The temperature of magma and the composition of magma can contribute to the new metamorphic rock. Geothermal gradient is also a contributing factor. Temperature increasing with the depth of burial, and the core of the Earth is usually warmer than the outer crust. Uniform pressure versus directed pressure. Lithostatic. Lithos means rock and static means unchanged. And uniform means non-directed. It is equal intensity from all directions by rocks.
Trust me.
Directed pressure. One direction of the pressure is squeezing is much stronger than the others. The minerals align themselves to reduce the stress. Types of metamorphism. Contact caused by igneous activity. Dynamic, aka cataclastic, and this is usually associated with faults and earthquake zones. And regional, caused by tremendous pressures and associated with tectonic plate activity.
Affirmative.
Contact metamorphism. Igneous intrusions, size and type of magma are important. The mafic magma is hotter than the felsic magma. Heat decreases away from magma, forms a zone of altered country rocks called aureoles. And this sometimes creates a metamorphic rock called the hornfels, in essence, a cooked rock.
I need a vacation.
Some pictures of metamorphic rock and of a salt dike with a country rock. Now, the second type of metamorphism is called dynamic metamorphism, aka cataclastic metamorphism. And this is associated with fault zones, places where the Earth's crust will rupture and rock is pulverized. The heat and pressure come from movement along the fault. Resultant rock is known as a myelinite. Here's a picture of some evidence of dynamic metamorphism. Regional metamorphism. It's the most common form of metamorphism caused by large-scale forces, lithospheric plate collision usually. It covers very large areas. Metamorphic belts are zones. Zones are characterized by the index minerals. They form under specific temperatures and pressures. Metamorphic facies. Indeed, this type of metamorphism, regional, is commonly associated with shields and mountains. Yeah. One characteristic of Hawaii is their active shield volcanoes, and this type of metamorphism is central to that island. Metamorphic textures include foliated. Foliose means page or leaf-like. Rock has distinct banding or layering. It's often not smooth like in sedimentary rocks. They're formed under directed pressure. And then non-foliated, no distinct layering character, often a massive crystalline texture formed under uniform pressures.
It's showtime.
Here's a picture of foliated texture and non-foliated texture. You can see that the forces are converging and pushing down on the foliated. That creates the effect. Now here's some examples of metamorphic rock. Marble is metamorphosized limestone. Quartzite, metamorphosed quartz sandstone. Here's another great chart of metamorphism underneath the continental crust. And that'll do it for presentation of metamorphic rock. Hopefully you enjoyed it, and we'll see you next time.
I'll be back.